guys! You have been studying for a while. What if we go to brisk walk?
Oh, let's go!
Wait! I need to do my makeup first. Mama, have you ever wondered that we can apply geometry concept in our makeup too?
Huh? Geometry? In makeup?
Yeah, look at your powder. It's shaped like a square.
I will explain how to calculate the surface area and volume of a cushion foundation container. First, I will calculate the surface area of a cushion foundation. Consider this is rectangular prism. For the formula of the surface area is equal 2 times area of base plus perimeter of base times height. First, I will calculate the base by multiplying the length and width. Then, I will calculate the perimeter of the base by adding all the sides. After that, I will substitute all the values into the formula. The surface area of the cushion foundation is 223.72 square centimeters. Next, I will calculate the volume of the cushion foundation. Formula for volume is area of base times height. First, we will find the base and then substitute into the formula, and then the volume of the cushion foundation is 197.184 cube centimeter. The measurement used in this calculation were taken from the product information on the official online shopping website, as the product cannot be measured directly. In conclusion, using this measurement allowed the surface area and volume of the cushion foundation to be calculated accurately.
Wow! I never thought makeup and nice to be related.
Yes, the surface area helped the designer know how much material that is needed to make the powder kits.
Hey, what are you guys talking about? Hurry up!
Hey guys, have you noticed the shape of this running track?
Yeah, it's like a circle. It is a combination of two straight lines and two semicircles. This shows that we can calculate the distance of one leg using perimeter formula.
So, let's take a closer look of this stadium design. To understand how to find the perimeter and area, we first need to break down the measurement of the inner grass field versus the entire stadium structure. First, let's look at the heart of the stadium, the green field. The flat part of the grass field is 64 meters long. The curved end of the grass have a radius of 28.5 meters. If you look at the center, the total width of the grass field is 57 meters, which is 28.5 meters times 2. Now, let's look at the dimension for the outer track, which is where we will do our calculation. The straight section for the outer part is 84 meters. The full width from the outer edge to the other is 73 meters. Because the total width is 73 meters, the radius for the outer curve is half of that, which is 36.5 meters. To find the perimeters of the track, we use the formula 2L plus 2 pi r. We multiply the 84 meters length by 2. Giving us 168 meters. We find the circumference of the two semicircles using 2 times 3.14 times 36.5, which is equals to 229.1 meters. Adding them together, the total outer perimeter is 397.1 meters, which is almost 400 meters. Finally, to find the total area of a walkway, we need to find the total area of the entire stadium first. The formula is pi times 36.5 square plus 73 times 84. This works out to approximately 10,315.27 meters square. Next, we calculate the area of the green grass field in the center. Just like the outer part, we combine its circular end and a rectangle middle using the formula pi times 28.5 square plus 57 times 64. This gives us a total grass area of 6,198.5 50.47 meters square. Now, for the final step is I need to find just the red walkway. We take the total stadium area and subtract the grass area. From the total, 10,315.27 minus 6,198.47. And there we have it. The final area of the walkway is 4,116.8 meters square. And that's how you solve it.
That shows geometry is used to design a standard running track.
Hey, look at the grass field. It is a shape of rectangle, so you can calculate the area for activities like football.
Now, for the grass field in the middle, it is a rectangle. To find the area of the grass field is length times width. If the field is 64 meters long and 57 meters wide, so for the area is 64 times 57 equals to 3,648 meters square.
So, geometry help us calculate distance for running and space for activities.
That's proof that geometry can be used in real life, especially when design.
Guys, let's take a break. I already ordered some pizza for us.
Since there are 4 of us, let's divide this pizza into 4 equal parts.
Yeah, we can apply the concept of area so that everyone can get the same area for the pizza.
So, before we divide this pizza into 4 equal parts, let us calculate the area of the whole pizza. Let us assume the pizza is a circle with a diameter of 28 centimeters, and the radius is diameter divided by 2. So, the radius is 14 centimeters. To find the area of the whole pizza, I use the formula for the area of the circle, which is pi times radius square. 22/7 times 14 square gives 616 square centimeters. Now, we can divide this pizza into 4 equal parts. To find the area of one sector, I divide the total area by 4. 616 divided by 4 equal 154 square centimeters. Before that, if only one pizza slice has been cut, what is the area of the uncut sector of the pizza? The angle of the uncut sector is 360 degrees minus 90 degrees, which equals to 170 degrees. Therefore, we can calculate the area of the uncut sector using the formula angle over 360 times pi r square. So, the area of the uncut sector is 270 degrees over 360 times pi r square. And the answer is 462 square centimeters. Not only that, from here, we can also see that a slice of pizza that has been cut has an angle of 90 degrees. This means that it is a minor sector because it has a value less than 180 degrees. The other uncut pizza has an angle of 270 degrees. This means that it is a major sector because it has an angle of more than 180 degrees. Next, I want to calculate the arc length of one slice of pizza. I use the arc length formula, which is angle over 360 multiplied by 2 pi r. So, 90 over 360 times 2 times pi times 14 equals 22 centimeters. We can also calculate the arc length of the uncut pizza, which is 270 degrees over 360 times 2 times pi times 14 equals 66 centimeters. Using the circumference formula, which is 2 pi r, we can also check whether the arc length calculation for both sectors is correct. For example, by adding the arc length of the major sector and the minor sector, which is 66 plus 22, the total is 88. Using the circumference formula, which is 2 pi times 14, the answer is also 88. Therefore, this proves that our previous calculation is correct.
Yay! I love how maths make it fair for everyone. Let's eat!
Hey Amani, why didn't you eat the pizza crust?
Oh, I don't like it.
Oh, so that means I can calculate the area of the pizza crust. Inside the sector, there is a triangle formed by 2 radius. To find the area of the triangle, I use 1/2 times a times b times sin 90 degrees equal 98 square centimeters. Finally, to find the area of the segment,
I subtract the area of the triangle from the area of the sector. 154 minus 98 equals 56 square centimeter.
Finish. Amani, can you put ice inside? I feel that I want to drink cold water.
Oh, sure, why not?
Now it tastes better.
Based on the situation just now, we can use the application of geometry to know the volume of ice that is added by calculate the difference between final volume of water and initial volume of water before the ice is added. So we consider that the radius of cup is 3 cm, the height of cup is 14 cm, and the depth of water is only 9 cm. To calculate the initial volume of water, substitute the values inside the formula of volume of cylinder, which is pi r squared h, which h is equal to depth of the water. By multiplying pi times 3 square times 9, we get the initial volume of water, which is 81 pi, that is approximately equal to 254.47 cm cubed. Same goes for the final volume of water. We assume it fills the cup completely without any spillage. So, substitute the values inside the same formula. Pi times 3 square times 14, which equal to 126 pi, that is approximately equal to 395.84 centimeter cubed. So, we can finally determine the volume of ice that is added by subtracting the initial volume from the final volume. So 126 pi minus 81 pi, we got 45 pi, which is approximately equal to 141.37 cm cubed.